Today, I want to show you guys how we can really enjoy learning math with Brilliant.work. And they are also the sponsor of this video. Here's their website, and let me take you to their course page first. They have so many courses for you to choose from though. We have foundational math, programming and CS, data analysis, and each lesson here is designed so that you can interact with their software, so the learning is actually very, very enjoyable and fun. And I know many of you guys, including myself, we like to do math competition questions. So let me take you to the contest math course, which is right here. We have different levels here. I'm going to do the trigonometric identity one with you guys. But if you want to do probabilities or combinatorial number series, it's there. All right, let's see. Continue. First, we have to find out which of the following is equal to, let's do this one real quick. Sine cube theta, cosine theta plus sine theta, cosine cube theta. So we just have to factor and clean things up a little bit. From here, we factor out sine theta. And from here, we can factor out cosine theta. And we will be left with sine squared theta plus cosine squared theta. So far, so good. And then sine theta, cosine theta stays. Sine squared theta plus cosine squared theta, that's equal to 1. We definitely have to know that. Right, so it's 1 right here. And sine theta times cosine theta is not one of the answer choices, But is there any other identities that has this part, sine theta times cosine theta? Yes, the one is that if you look at the double angle identity for sine, sine of 2 theta is equal to 2 sine theta times cosine theta. So from here, if you divide both sides by 2, we can see that this is just equal to 1/2 sine of 2 theta. And that must be the answer right here. Check the answer. We got this right. And suppose that you didn't know the identities, or if you got this wrong, of course you can just click on why, and then they will show you guys the explanation, which is the one that we just did right here. Okay, continue. Next question. Okay, compute cosine of 36 degrees. I know the answer by heart because this is a famous one. And then you can also do triangle to figure this out. But I am actually just going to pick a wrong answer on purpose and then show you what will happen. I'm going to pick this one, 1 plus square root of 5 over 2, because I think that's the golden ratio, right? It's wrong. It's not just the golden ratio, you'll see. Anyways, check. Okay. I'm going to just click on C answer. And okay, it's this one. But why though? Let's have a look. I want to see how they do it. Okay. So first we have cosine 72 degrees is equal to 2 cosine squared 36 degrees minus 1. They use the double angle identity for cosine. And then they did it again. Right here, cosine 144 degrees is equal to 2 cosine squared 72 degrees minus 1. Okay. And then notice that cosine 144 degrees is equal to negative cosine of 36 degrees. The reason is because 36 degrees and 144 degrees, they are complementary. They are supplementary angles. They add up to 180 degrees. So 36 is on the past the x-axis direction in the first quadrant. 144 degrees is in the second quadrant. When you are in the first quadrant, the x value is positive. When you are in the second quadrant, the x value is negative. And it's the same distance, but one is positive, the other one is negative. That's how you can see it real quick. And they have this, right? Negative cosine of 36 degrees is equal to 2 cosine squared 72 degrees minus 1. They plug that in, they expand this, and they get that. Also, they have an equation in terms of just cosine of 36 degrees. and then they call cosine of 36 degrees x. And you can see that that x has to satisfy this equation. So now we are talking about a quadratic equation, right? Degree 4 polynomial. To solve that, well, we factor it. It's not too bad. You can use the synthetic division and all that. But if you're not too familiar with this, definitely try out their algebra course or the algebra lesson in the contest math course. Okay, when we have a quadratic equation, we can possibly have 4 different answers, right? But cosine of 36 degrees is just one value. Make sure that we rule out that cosine 36 degrees is not equal to 1/2 and it's not equal to -1, because cosine of one angle is equal to 1/2. Well, you let me know. And how come cosine 36 cannot be -1? Well, again, you let me know. But anyways, we just have to solve this quadratic equation now. Use the quadratic formula, we get this. But again, just one answer. Cannot be plus or minus. The answer is 1 plus square root of 5 over 4. It has to be positive because 36 degrees is in the first quadrant. It's actually half of the golden ratio, right? So that's how I remember the answer for this. But anyways, all right, next one. We're going to solve this equation. Let's do this one together. Sine theta. By the way, though, I usually like to do math on paper, but today I had to record this, so I'm doing this on my iPad. Anyways, sine theta plus cosine theta is equal to square root of 6 over 2. All right, to solve this, and we have to find the smallest positive theta, I'm just going to square both sides because for now we don't really have an identity that's nice enough to do this. Yes, you can use the, I think that's called the harmonic addition theorem or the R theorem, but I think a slightly more straightforward way is you can just square both sides. Imagine that you are doing this on math competition, you are to do this fast, and if you have forgotten about the harmonic addition theorem, then square both sides, I think it will be quicker, in my opinion. But anyways, this right here, expand the left hand side, sine square theta plus 2 sine theta cosine theta plus cosine square theta, and that's equal to 6 over 4, right? And notice this and that is equal to 1. And then we add 2 sine theta cosine theta is equal to sine of 2 theta, right? The double angle identity. And 6 over 4 is equal to 3 over 2. And then subtract 1 to both sides. That means sine 2 theta is equal to 1/2. Okay, sine of what angle is equal to 1/2? Right, the smaller one, right? 30 degrees. So that means the input 2 theta has to be 30 degrees. Divide both sides by 2, theta is equal to 15 degrees. And that should do it. Yay. And again, you can click on Y, but we did it, so now. Okay. All right, so let's see what we have next. Okay, we're going to compute cosine 1 degree plus cosine 2 degrees up to cosine of 360 degrees. There must be an easier way to do this, right? Of course, we have to use some identities. Oh, I see the answer. It's not because I knew the answer. I see it. It's actually one of the things that we have gone through earlier. Remember, if you have this and that, if it went on the, I don't know, like the direction because I'm looking at the camera now, but if you're in the positive x-axis and also in the negative x-axis, when they have the same length, Well, when you add them up, they'll just cancel, right? The answer is just equal to 0 for this. You'll see, because I'm going to show you. Okay, got it. Oh, let me see why. This one right here, cosine theta is equal to negative of cosine of 180 degrees minus theta. And that's why I said earlier. So cosine of 1 degree is equal to negative cosine of 179 degrees. So all the top, when you add them up, it's just going to be 0. Likewise, all the bottom is going to be 0. So yeah. Okay. All right, next, compute cosine 12 degrees cosine times cosine of 24 degrees times cosine of 48 degrees times cosine of 96 degrees. The angles are just multiplied by 2, huh? So we should somehow utilize the double angle identity. All right, now let's see. Cosine 12 degrees, cosine 24 degrees, and then we don't have 36 degrees, I think, because we did that one earlier. I have no idea why they didn't have that. Oh, multiply by 2, not adding 12, sorry. So multiply by 2, so it's 48 degrees, and then 96 degrees. Okay. So if we recall cosine, the double angle identity, 2 theta, this will be 2 cosine squared theta minus 1. But I don't really think this will be any useful, because it looks like we will make the expression harder. However, if we look at sine of 2 theta, this is 2 sine theta cosine theta. So if you look at this one right here and divide both sides by 2 sine theta, we can say cosine theta is equal to sine 2 theta over 2 sine theta. Why did I do this? It's because you see that we have a fraction. In fact, once you have this, you can see some cancellations very, very nicely. So let me utilize that, all right? So firstly though, I'm going to do this one in black, of course. Cosine of 12 degrees, so that will be the angle, right? 12 degrees. So just have to make sure we enter 12 degrees, and we will have sine 2 times 12 is 24 degrees over 2 sine 12 degrees. That looks like 120, no. Next one, cosine of 24 degrees, same thing. That will be sine of 48 degrees over 2 times sine of 24 degrees. Continue, sine of 96 degrees over 2 sine of 48 degrees. And lastly, let me move this a little bit. We have sine of 96 times 2 is 192 degrees over 2 sine of 96 degrees. Told you, we are going to see some cancellations. We have this and that cancel, this and that cancel, this and that cancel. Very nice. All right, thanks to this identity, but we don't need this anymore. But what exactly do we have now though? On the top, we have sine of 192 degrees. On the bottom, we have a total of 1, 2, 3, 4. 4 2's multiplying together, so that will be 2 to the 4th power, and that will give us 16. And then we have sine of 12 degrees. Okay, is there anything we can do with this though? Yes, have a look. Sine of 192 degrees is just 180 degrees plus 12, right? So that must be something. So I'm actually going to look at the top as sine of 180 degrees plus 12 degrees over 16 times sine of 12 degrees. Now, remember the unit circle. It's really, really useful. So here, let me show you. If you have a unit circle, right? Sine is the y value on the unit circle. So let's say this right here is 12 degrees. So this is, again, the y value is the sine value. If you add 180 degrees, then it's going to be right here. So as you can see, in this case here, sine of 12 degrees is up here, but sine of 192 degrees down here. The distance is the same, but one is positive, the other one is negative. So this is what we can do. All we have to say is the top is just going to be negative of sine of 12 degrees, isn't it? Yeah. And then of course the rest is just more cancellations. Cancel this and that. And finally, ladies and gentlemen, we see the answer is negative 1 over 16. Got it, of course. All right, they are giving us a warning that sometimes the trig functions or the identities might not be given explicitly. Okay. This is a very, very fun one. When I first saw this, is that wow, I actually didn't know that I could do something like that. So I'm going to do this one with you guys, and then the last one I'm going to ask you guys to try it, and you guys are going to leave the answer for the last one for me. All right, so here we are given that we have a sequence, and we know that a1 is equal to 1/2, and then we have an plus 1 is equal to 2 times an squared and then minus 1. And this is true for n greater than or equal to 1. And we are trying to figure out what's a10, right, the 10th term. Of course, you can just plug in 1/2, work that out, and then plug in that result into the formula and keep working that out, right? That's totally okay. But recursive formula, it's not easy to compute if you just do it like this. Is it possible for us to solve for an explicit formula for this though? Maybe, but it's an squared. It's not so easy. However, here is the key. They gave us a hint already earlier, right? Sometimes trig identities might not be explicitly given. So let's see. We have this thing is equal to 2 times something squared and then minus 1. Doesn't this look like something that we used earlier? And the answer is what? The double angle identity for cosine. So note, if we are looking at cosine of 2 theta, this right here is just equal to 2 times cosine theta and then square that minus 1. I put on the square up there on purpose because now I want to show you. This right here is what we have for an, and this right here is what we have for an plus 1. And this is really cool. So now here's the deal. I'm going to write a1 as cosine theta. That's the starting, right? And then the next one, a2, it will be cosine of 2 theta. You just double the angle. And then the next one, a3, again, you just have to double the angle again. So remember, it's 2 times 2 theta. That will give us 4 theta. So we see a pattern. The next one will be cosine of 8 theta, and the pattern continues. And our goal is to get to a10. That would be cosine of, well, we will have to multiply 2 a total of 9 times from 1. So that's 2 to the 9th power, which is 512, and we need a theta. Let me denote that. This is because 2, 10 minus 1. Just like earlier, A3. This is a 4 because 2 to the 3 minus 1 power, 2 to the 2nd power, which is 4. Now, we know that A1 is equal to 1/2. So, from here, we can see that cosine theta has to be 1/2. Okay, cosine of what angle will be 1/2? We can use what? 60 degrees, which is pi over 3. So theta is equal to pi over 3. So that means A10 will just be cosine of 512 times pi over 3. Okay, how do we figure this out though? 512 pi over 3. Here's the deal. Do long division. I'm just going to do 512 divided by 3. That will be 170, and the remainder is 2. So this means we are going to look at this as cosine of 170 pi plus 2 over 3 pi. 170 pi. The key right here is that this is 85 times 2 pi. So we're just adding 2 pi a total of 85 times. And because the period for cosine is 2 pi, this right here does not matter. This right here is the same as saying cosine of 2 pi over 3. What's cosine of 2 pi over 3? It's just the negative version of cosine of pi over 3, which is just going to be negative 1/2. And that's the answer. Let's have a look. We got it right. All right, here's the last one for you guys. It's very, very cool. We have a sequence AN, and A1 is equal to 1/2, and then we have this formula. And once again, we have to figure out what A10 is. Go ahead and try this one on your own. And that's it. This is the last question on this part of the lesson. I hope you guys all enjoy it. This is from Boolean. It's a wonderful place for you guys to go and learn math. Now, if you want to try Boolean, go ahead and use the link in the description, boolean.work/blackpen redpen, because that way you can get 20% off of your annual premium subscription. Go ahead and try it. I want to thank Boolean for sponsoring today's video. I also want to thank you guys for checking them out.